Sup guys, welcome to today's show. In the last episode we started a new project called Esther. And Esther is an Ethernet implementation, a library that we can use to send anything we want when it comes to networking. We will basically send the data directly to the network card. So we will be able to spoof IP packets by sending packets with a different IP address than our own. You should not use it for that, but that's one way of using it. Another thing is we will be able to monitor traffic on the network, for instance. And we can do a whole lot of different other stuff. So basically we set up the project the last time and added some utility functions for printing MAC addresses and converting between MAC addresses and our Ethernet date structure and so on and so forth. So today we are going to create our eval function, which is going to take one of these Ethernet data structures and turn it, this one. No, where is it? Here it is. So this is our Ethernet data structure, and we're going to turn it into something like this, but also with some data. So I think I'm going to do it like no, let's do it like this for now. Alright, so first off, I want to make our lives a little bit easier. Currently, if we, for instance, evaluate our IP packet or our IP data structure, it's going to return an int8 star, which is just a number of bytes. Yeah. But it would be easier if it could return something which returns the bytes, but also the size. So we don't have to calculate it manually each time. So that's where I'm going to start. I'm going to create a very simple new data structure, which I'm going to call a byte string. And it's going to look something like this. So we're going to have an int16 size, and then we're going to have an int8 data. And it's going to be packed, and we will type def struct as byte string into a byte string like this. So this will make stuff a little bit easier. And let's create a constructor function for this thing. So let's see here. It's going to return a byte string pointer. And by the way, let's not do it like this. Let's just use the pointer we have. So let's do it like this instead. So we're going to have a make byte string, which is going to take an int8 star and a size, so an int16. So make byte string and int8 data, int16 size. So let's first check that if we don't have data, or if we don't have a size, we'll return an error. Otherwise, we're gonna calculate how big this needs to be, which is just size of struct s byte string. Then we're gonna malloc this size. Let's assert that we have a BS. Let's zero it out. And fill in the contents. Something like this. So let's take this eval ICMP and let it return a byte string instead. Same with the one for IP, and same for eval ether. So let's start with the eval ICMP. Or actually, we don't need a variable. So let's see which one contains the size of the thing. This one. So we're going to return make byte string, and we provide ret and size. Then we take eval IP and do the same. So let's see here. We have a ret which is equal to p, and we have the length little endian. So make byte string of ret and length little endian. And eval either we haven't. Yes, we did actually do this one. So we're returning this p. And we're currently only evaluating the header. Maybe we should take the rest as well. So something like this. And I wonder if we need to update some other stuff as well. Let's see if anything is calling eval IP. No. What about? But it's calling the eval function, I guess. Let's check eval ICMP. Okay, here we call it ICMP pointer is equal to this. So let's create a byte string pointer instead. And let's just do eval. So if we have a BS and, well, this is enough. Then we can set the ICMP pointer to BS data. And it shouldn't be necessary to do this calculation. Instead, we can just use byte string size. I think this is right. Alright, so I think I'm going to create a function which merges two of these things as well. So let's have a byte string section. So let's say we have a BS merge, and it takes two byte string pointers and merges them into one. Let's also create a function pointer where we have a byte string let's call this BS function, and it takes 2 byte strings. And then we can do a little bit of object orientation to make stuff even easier. We can add a byte string function which we call merge, something like this. Let's make this static. And when we create one of those with a make byte string, we can set BS merge equal to the address of our BS merge function. Let's first check that we have those two. That not both of them are empty, because then it's an error. However, if one of them is empty, so if, let's say if A is empty, then we can just return B. And if B is empty, we can return A. Otherwise, we need to be a little bit more clever. So the size is going to be equal to well, let's start with the size of the data. So that's the A size plus B size. And then we allocate. Let's clear it out. And then we copy into P. A data with A size. And we increase P by A size. And then we copy into P B data with B size. So now we have a new data area. We can free the A data, we can free the B data, and we can free A, we can free B. Let's assert that we have a P. Now we can create the new one. So we need to have one more size variable. Let's assert that we have a BS, and then we zero it out. And now we just need to set the fields. Actually, we don't need to do the allocation and stuff in here. Actually, when we have the size and its contents, we can just return make byte string, and we provide the let's see, we need to have another pointer. So when we have allocated, we can set ret to P, and we can return ret and well, we don't need this n either, because this size calculation will happen inside of the make the constructor function. So we can remove this, and we can just say size here. So now we can merge two of these. So let's test this out. Let's create main3, where we have 2 byte strings, B is 1, B is 2, and need to have 2 data fields as well, so D1, D2. Let's say D1 is equal to hello, d2 is equal to world. And I guess we need to cast this. So let's create some byte strings. So bs1 is going to be make byte string d1, and hello is 1, 2, 3, 4, 5, 6 bytes. bs2 is 1, 2, 3, 4, 5. Let's do some error reporting. So if we, let's do this instead. So bs1 is equal to bs1 merge bs1 and bs2. I think we can do it like this. If we don't have a bs1, otherwise let's print some stuff. I'm not sure if this is going to be null terminated though. Maybe we can include a null terminated by doing 6 bytes here. And then we can free bs1 and we can return 0. And our main is main3. Alright, let's see if we can get this to work. By the way, I'm annoyed by this warning. So let's remove this. If you know that the warning is not correct and you are disturbed by it, you can just copy this thing right here. And then you go into the make file and add a flag where you paste this in, and after the W you add no dash, and then the warning should go away. Let's see, expected declaration specifiers. Unknown type name byte string. I think we need to move it down a little bit. Unknown type name base function. (143). That's right. We have a little bit of hen and the egg situation here. In order to create this, we need to have this, and the vice versa. So maybe we just need to do something like this. Let me try something. If we take this type definition and put it above here, and first we just declare that we want to have something which is called byte string, but we're not telling what it is. Then we can type def, and then we can do this, and then I guess we can do this here. I think this is going to work. That's more like it. Oh, I call it BS here. But I think I called it the right thing inside of the C file. Alright, conflicting types for eval IP, int 8 eval IP. So let's try this again. Returning blah 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 from a function with incompatible return type byte string. Int 8 eval ICMP. I forgot to change all of these. So eval ICMP should be a byte string. Eval IP is okay. Eval ether should also be changed. And what's this about the macros? What are they referring to? In function eval ICMP. Let's go from the top. In function eval IP, line 51. Inside of the H file, 51. But that's the macro. Where does it happen? Ester.c 1 4. Oh, it's the zeros. Alright. So let's go into this and let's go to eval ICMP. When we return errors, we need to return the right thing as well. Then we go to eval IP. We have a couple of those as well. Eval Ethernet, same here. Okay, now I think those arrows should be gone. $152. Oh, I forgot one. And now I believe we should be down to one screen of errors. Almost. There's still one of those. $234. It's always a lot of work to change return types of a couple of functions. Okay, that's better. Okay, that's the warning that we had before. Didn't I remove this? Int to pointer cast. no point. Okay, so point to, there's both directions. So there's int to pointer and pointer to int. Implicit declaration of make string. That's right. So 455. This should of course be make byte string, nothing else. Incompatible types when assigning type byte string star from type byte string. So I guess I was right the first time. Called object is not a function or function pointer. Assignment to byte string double star. Struct s byte string star. Struct byte string, byte string, star, star. Is it like this, perhaps? It's always a little bit tricky with those function pointers. Error, field merge declared as a function, okay. Now it compiled. Let's try this out. Invalid pointer. That's interesting. Are we freeing too much? Right, we're trying to free those, and they are read-only. So let's do something like this, just for the sake of testing. The string cat is a concatenation function. oh, I meant string dupe, which just duplicates a string. Huh, it works. So now we're able to merge two of these, which will make stuff quite a bit easier. So let's check our data structures. Let's move those closer together. So we have this and then the raw version. Then we have the two ICMPs and two IPs. Let's change so this goes before the raw version. Alright, so let's see. So we have the Ethernet, then we have a payload, which is an IP packet. Then we have the IP and we have a payload which currently is only ICMP, but it's going to be supported TCP and UDP as well. So I want to make it so when we evaluate Ethernet, it's going to evaluate the header but also the payload. So it's going to evaluate the next thing and the next thing. And I think the IP version does that already. So eval IP. Yeah, so we don't just need to add that to our Ethernet. So eval ether. So when we have done all of this, let's create a byte string pointer. Let's call this BS1. So if our Ethernet does not contain a payload, then we are done and we can just return BS1. Otherwise, we can set BS2 equal to eval and we provide the E payload. And if we don't have one of these, we can return the first one. or I guess it's better in this case to return an error. So we can free BS1 data, we can free BS1, and we can return an error. Otherwise we have 2 byte strings which we want to merge. So let's just return BS1 merge BS1 BS2. Easy peasy. No need to calculate all different things. Let's see, did I update the macro for eval? No, we don't have the Ethernet here. So ether star, we want to do eval ether. Like so. And we should have a show function as well. Something like this. And let's see here. So the show IP takes an int 8 and an IP and returns void. So we need a void show ether with an int 8 star and an ether star. And I think we can just copy the IP function and edit what we need. So show IP. So let's see if we have a payload. Why do we do these calculations? N. What do we use N for? Here, bytes total. So we have the raw IP packet plus the payload. Raw ICMP Maybe we should call this E instead. Let's say we have an IP packet. If we have or let's add instead, if we have an E payload, we want to set packet equal to the E payload. So then we can still run all of these calculations, but we'll do n plus equals instead. And we need to enclose all of this. So let's see here. Packet payload size. So n needs to be equal to size of struct s raw ether and we add e payload size. Is there no size here? Maybe this works. And if we don't have a payload, n will only be equal to the size of struct s raw ether. And we also need to take care of the MAC addresses. So M1 is equal to show E destination M2 is the source. So we'll have a size, and kind I think we should add as well. Or maybe not. And there's no ID. We will have source though, which is M2, destination M1. What else do we have inside of this structure? The protocol. And this is a 16-bit integer, so 04HX. So E protocol, something like this. All right, I think this is right. So let's try this out. Let's say we have another main. Or actually, maybe we can reuse one of these, because I think we have done something similar already. So here we create a Mac. No, let's create one new. Alright, so what do we need here? We need to have one Ethernet thing, so E, and we need to have two MAC addresses. So let's say we have MAC source and destination. And let's say the source is equal to make Mac, something like this. And let's say the destination is the broadcast address of all Fs. Then we can create an E using make ether. So first we need the ether type. So we have T IP. Then we have the destination and the source. And now we can try to show this thing. So we show E. Then we free it and we return. And maybe we should also free the MAC addresses, like so. Okay, so in this case we're gonna have an empty Ethernet frame. And let's see if we can show that thing. Unknown type name IP. Okay. Maybe the reshuffle inside of here wasn't too good. Let's take this and put it up top. And we'll do the same trick. Struct this IP. Conflicting types for show either. Have void int 8 star, void unsigned char. Struct as ether star. Previous declaration of show either with another type. Is that so? Show ether. Show ether. Previous declaration. I don't have any more declaration. 69, 173. Oh, I void star. That's right. Easy mistake. Cannot convert to a pointer type. M1 is equal to show. Cannot convert to a pointer type. 74. So show Mac int 8 star. Okay. Int 8 star. E destination. And E source. Okay. This needs to be pointers. Five, 4, 9. Now I believe it should work. Alright, so ether E is equal to this, 14 bytes total. We have a protocol, which is this. We have a source and a destination. It looks quite nice with the tabs and all. Somehow it became right aligned, which is kind of cool. But it works. So let's create an IP packet and see if we can add that to this thing. So how do we create an IP packet? What do we need? Make IP. So we need to have a kind. And I guess that is L4 ICMP. And the source as an int 8. So let's just do this then. Let's say we're sending from 192.168.12.1 to a destination, and let's send to the broadcast. So 192.168.12.255. And we need an ID. I think we can leave these as 0. But we need to have this counter. How does that work? Well, I think we can just do something like this. How big was that counter? Int 16. So let's say we have an int 16 counter, and we have an int 16 counter pointer, and let's set the counter to 5, counter pointer to the address of counter, and then we can provide it here. And I guess that's it. So now we only need to set the E payload equal to the IP packet. It compiles. Look at this. So we are still just showing the E, but it shows all of this as well. So everything is starting to work as expected. And if we were to create a byte string BS, set it equal to eval e. So if we are able to evaluate this thing, let's print its contents. So print hex, no, what do I call it? Oh, it's called print hex. So print hex and int 8, int 16, int 8. So we take the B. We take the BS data, the BS size. Let's have a space as the limiter. Something like this. This should be IP packets. 5, 6, 7. Why does not this work? Weird. Okay, so this is the data. First we have the destination MAC, then we have the source MAC, then we have some stuff I don't really know. But it looks right. So now we have successfully been able to evaluate the Ethernet and everything within. Yeah, and that's all the preparations we need. The next stuff we're going to do is take care of the sockets, the packet sockets. So we'll be right back after this. All right, welcome back, you guys. So before the break, we managed to get this stuff to work. We are now able to create an Ethernet packet and evaluate it down to the actual bytes that we want to send over the wire. So the next logical step is setting up all the socket stuff and creating a function for sending an Ethernet frame with the containing IP packet and so forth. So let's first see what we currently have. We have some kind of setup function. Here it is. And currently we are creating a regular raw IP socket. So we need to change this setup function so it becomes a packet socket instead. So let's check the manual page, man packet, and we need a couple of includes. There we go. So let's see, syssocket.h, we have already Linux IF packet, we need Ethernet.h, I don't think we need, but let's keep it for now. Alright, so a packet socket uses this, AF packet, we need to define a socket type and a protocol. So let's take this thing and go to our setup function and change AF inet into AF packet. And what about the socket type? Either sock raw or sock datagram. And we need the sock raw, which we have. And then we come to the protocol field. When we're dealing with the regular raw sockets before, we need to specify a protocol, and it will only catch that protocol. But now we have the possibility of doing this stuff. So we grab all the packets, and that's what I want to do, because I want to differentiate between them myself. And I want to have the ability to, to capture all packets on the whole network if we wishes to. So this is good. And what about this header include? Do we still need that stuff? Let's go to the socket option, fan out, loss reserve. No, I don't think we need this. Let's keep it in a comment just in case. I'm not sure if this stuff is compatible, but let's keep it for now. So this is the timeouts. Currently we have a timeout of, well, whatever we define the timeout to be. I think it's 2 seconds or something. And I think I want to keep that. Perhaps we should lower the timeout, but let's not care about that for now. Let's see if we can still use this stuff. So let's define yet another main function. And this time, let's say, we have an int main, and let's use the arguments as well. And I believe this is going to be main number 5 or something. Yes. So we're gonna have an int and a char double star. So we can give it some command line arguments. So let's call main 5 and provide the argc and argv parameters. And inside of here, I want to have a, let's check if argc is less than something. I don't know how much at the moment. And in that case, we want to print an error message or a usage message. So let's print it to standard error, and the usage is going to be the name of the file. And this version is going to send one single Ethernet frame. So let's provide the source MAC address, destination MAC address, the source IP, destination IP, and the message. Yeah, let's do it like this. And then we return -1. Alright, so we have 1, 2, 3, 4, 5 arguments, which means that we want to check if this is less than, let's see, if we had 1 argument, we would put a 2 here, so a 6, I guess. Because it's going to be 1, 2, 3, 4, 5, 6, maybe even 7. So let's create some variables to hold these things. So we need to have a Mac, let's call this Mac source and Mac dest. And I don't remember if our functions return pointers or the actual thing. They return pointers. And similarly, we need to have the IP addresses, and those we can keep in int 32s. So IP source, IP dest. And we'll let the message be an int8 pointer. And I will not add a lot of error correction and stuff here. So Mac source is going to be equal to make Mac based off of the first argument. Same with the destination. That's the second. And the IP address is, I'm going to use the inet address function to convert the string into an integer. Same with the destination. 1, 2, 3, 4. And then the message, we can just do an int8 cast from argv 5. And if any of these are 0, we can quit. I will not do anything more advanced than that. And let's see. Let's do a macro out of this. So we're going to define a usage. We'll do this. While false. We need to give the, that's right, I forgot that. Since we're using this way, we need to provide the argument. So that will be the x in this case. And then we can just do something like usage argv. Same here. Pretty clean. Alright, so we need to keep an int32 for the socket file descriptor. So let's call this fd. Fd is going to be equal to the setup function. Something like this. So at this point, we should have everything. So let's just print an OK message. And let's free up some stuff. We can close the FD. We can free Mac source, free Mac dest. And return 0, just to see that everything works as expected. Which it didn't. As usual, I forgot all of these slashes. For our macro magic. And yes, these are unused. So let's for now just do something like void mac source and mac dest. And this is just a trick to do something with these variables and silence those messages. It will work when we use them later on. Still some errors. Those sneaky little backslashes, eh? One set but not used. That's right. Okay. So let's see here. We need to convert this to an int 8, like so. And this we need to convert into a char. And let's also fix this one variable. And now I believe it will compile. Almost. Destmac undeclared. This file is getting a little too big, I think. So let's see, destmac, what did I call it? Macdest, okay. And maybe we need a semicolon here. And now I believe it will compile without any warnings. Yes. Huh. That's interesting. Oh. We should do this should be argv0. Same here. Okay, that's better. So let's see. Let's say we have a source MAC of, well, let's check the network card. We don't necessarily need to use the real MAC, but let's anyway. So let's see here. Yeah, this is the one. We need to convert it into our format like this. And let's say the destination is something like this. Some IP addresses. Okay. Maybe I was right the first time. Alright, so socket failed. And that's probably because we're not root. Let's check that. Huh, okay. That sounds good. Let's do a check from the beginning. see that we are root before or maybe inside of the setup. Yeah. So let's make our lives easy and just do assert that get UID is equal to 0 to be specific about our intent. And maybe we need some include for that, I'm not sure. No? Yeah, looks right. All right, so we were successful in creating the actual socket. So now we need to have a function which sends one of these packets. And I think we can create that function rather easily because of all the hard work we did during the creation of all of these evaluation functions. So let's see here. Let's create something like bool send frame. And what do we need to give as arguments? We need to provide the socket file descriptor. And what else? How are we gonna do this? I guess we could just provide an Ethernet structure and put everything in there. Yeah, I think that's good. Because all the data and everything will be inside of that thing. So in our main function, main number 5, instead of printing OK, we are going to set up one of these things. So we need an Ethernet structure. Which we'll create using the make ether. And we need to provide an ether type. So let's say type IP, a destination MAC address. We do have one of those. So MAC dest and MAC source. But what about the data? Right, that will be inside of the IP packet, which means we need one of those too. So we'll make IP. And what kind is this going to be? I think we have a kind for ICMP only at the moment. Let's see, if we go to the IP, we have a type kind. So it's one of these here. And since we are at layer 3, the thing we are describing are the layer 4. So we have ICMP, TCP, and UDP. Maybe we should have one for, I don't know, a raw version. which is just a message without anything else. Yeah, I think that's good. Problem is, how does our make IP handle that kind of stuff? Okay, it just takes the kind like this. But that suits us fine, actually. So our packet is going to be L4 raw. The source address, okay, it takes the source address as a string. So we can't do it like this. We will just do something like this instead. Then we can just provide IP source, IP dest. Right, we need to have those IDs and counters and stuff. So an int16 counter, int16 counter pointer. Start the count at 0. A count pointer is going to be our counter. We provide the counter pointer. No, first the ID, right? But we can set it to 0 and we set this to the counter pointer and it will generate the ID for us. So let's make sure that we have Ethernet IP. Not the best user-friendly error message, but never mind. Alright, so now we want to take our Ethernet packet and set the payload equal to our IP. We'll take our IP payload. No, it's called IP packet. Our IP packet payload is going to be, let's see how we define this. Okay, it only takes ICMP at the moment. That's not good. Let's create a union. Let's see. Let's do union U. We can call this layer 4. we will type def our union u layer 4 into just layer 4. And instead of saying ICMP payload, we will say layer 4 payload, like this, I guess. And let's define our union u layer 4 as either ICMP packet or raw packet. Which means we need to define what a raw packet is. And we can do that pretty easily by just type def int 8 to raw, something like this. So let's see, when we evaluate the IP, so make IP, no, not make IP, eval IP. How does it handle this? Okay, it has a case for L4 ICMP. And this is hard coded for the raw ICMP. Let's see, where else do we do anything with the payload? Here. And we eval the payload. So we need to have an evaluation function for the raw version as well. Calling this an ICMP pointer is not the best way either. Maybe we should rewrite this function. It's not going to be very pretty now, but not much we can do for now. L4 raw. And I guess the protocol will be 0 in this case. Instead of plusing this, we can do a ternary. So if packet kind is L4 ICMP, in that case we will do this. Otherwise, we will not add anything. And what about this stuff? We will evaluate this and get a byte string back. PS data. Let's skip this part and just copy the byte string data. And we can remove this ICMP pointer entirely. Like so. And now we not just need to write a very simple evaluation function. Let's make this very simple. So it's going to return a byte. It's going to return a byte string, eval raw, and it's going to take a raw packet, and we will just return make byte string. And we provide the raw packet. And we need to have the size. Do we have some string length function? Yes, we do. So let's use it and just take the length of the int8 version of the raw packet, like this. Pretty nice. And now we just need to add one line to our evaluation function. So if we have a raw, we want to run eval raw with the raw pointer of x, like so. No, my touchpad is getting a little bit annoying, to be honest. I think this is going to work. If we go to our main 5, so the IP packet payload, it's going to be equal to let's see here. I guess we will just do raw star and provide the message. think that will be good enough. So now we have the Ethernet, we have the IP, we have the layer 4 packets. Now we can call our functions. Let's have some return variable, something like ret perhaps. Let's set it equal. Let's do this first. Then we set ret equal to send frame. And we have our file descriptor and we have our Ethernet. So let's see here. If we have a positive return value, we want to provide true, otherwise false. Something like this. And now we just need to create this function for sending the frame. And it's going to be pretty easy, I think. I hope. So it's going to return a bool, send frame. And we need an int32 FD and an Ethernet E. And if we don't have one of those arguments, we return false. And we need to have a byte string which we get from just evaluating the Ethernet packet, and then we have all the series of bytes. We need to have a signed integer for the return value. So let's see, which system call are we going to use for sending this thing? I think we should use send, but I'm not sure. Let's see here. File descriptor, buffer, length, and possibly flags. Let's see if this is compatible with the Ethernet packet socket. Because in that case we can just do ret is equal to send, and we provide the file descriptor, we provide the byte string data as a char, and as an integer we provide the byte string size, and then 0 as flags. And we return ret. I don't think there's much more to it actually. Let's see if this thing compiles. Payload has incomplete type. And sure enough, it does. But with structures, we can do that. But apparently not with this stuff. So we need to be a little bit more clever, I guess. Let's remove this from here. And we'll do the type def union u layer 4 into layer 4. And this is 1, 2, 3, 4, 5 lines. And we need to put this above here. And do we have the ICMP? Yes, we do, right? Yeah, I don't think we need to change anything else. Incompatible types when assigning to type layer 4 from ICMP star. That's right, 63. So this should be layer 4 instead. And I guess it shouldn't be a pointer. Cast to union type from type not present in union. That's a little bit annoying. So how do we zero this thing out? Can we do just this perhaps? Nope. So let's do something like this. We set it to false. And we add some bogus value. It will not create any real, what's it called, overhead. So let's just say bogus, no, bool, bogus, or something. Let help. maybe we can do something like this then. So let's cast this into a raw. And we'll say this is the packet payload dot raw packet. That should be the same result. Alright. Used union type value where scalar is required. 88. So if packet payload raw packet, let's say, same here, raw packet. But the raw packet does not have a size. This is the problem when we rewrite some software to do something not the same. How do we do this? Well, I guess we need to do a ternary here as well then. So we're going to plus, and if we have a packet, so let's see, the packet is the IP packet, kind equal to L4 ICMP. In that case, we want to plus this, but this is going to be the ICMP packet size. And otherwise, we will do the string length of the packet payload dot raw packet as an indate. Not very beautiful, but it's gonna do the trick. .124 has the same problem. So if payload dot raw packet, and to be specific about this. When I do this check here, I'm not checking if this is a raw packet per se. I'm checking if this pointer is 0 or not, so it can refer to an ICMP pointer as well, just so you understand that. Alright, so let's do a ternary here as well. If our packet kind is L4 ICMP, then we want to plus this thing. Otherwise, the string len of packet payload raw packet as an int8, like so. But why do I have this check here as well? Here I add, I add the header. That's sensible, actually. Same problem here. 127. This needs to be the dot ICMP packet. The same problem at 143. Dot raw packet. Or maybe we can actually do ICMP packet here just to communicate our intent a little bit better. Same here. If packet payload needs to be if packet payload raw packet. And here we do a check for L4 ICMP and we add the header. So let's move this into this ternary as well. So we're going to plus the packet payload dot ICMP packet size. Otherwise, we will just take the string length of packet payload raw packet. And this ought to fix that stuff. Hopefully there's not much more of this. But it is 220. Right, this should be removed. $248. This is getting old. Packet payload raw packet. cannot convert to a pointer type 251. Guess we need to do a ternary here as well. So if the packet kind is L4 ICMP, we want to eval the packet payload as an ICMP packet. Otherwise, we want to evaluate it as packet payload raw packet. Lot of ternaries. Alright, so let's see here. 34, I guess we're missing a comma. Yes, we do. Eval raw, implicit declaration. Okay, what did I call it? Eval raw. Okay, I never created one of the signatures. So byte string eval raw, and it takes a raw star. E465. Okay, now we're down at the main function. Or okay, send frame. Eval, and this is just E. A lot of small typos. And now we're down to one line. Expected specifier qualifier list before raw. $34. I've never seen that error before. Specifier qualifier list before raw. Let me think a little bit about that, and we'll be right back after this. Sup guys, welcome back. So before the break, we managed to create our function for sending a frame on the Ethernet network. So now we're gonna do the troubleshooting. So let's see here where we're at. Right, we're having some problems with this raw thing. So let's see if we can figure this out. So what we want to do with this code is, if we call this eval function or macro, and we provide something of the type raw, then we want to call the eval raw function. Same as we have done with the other ones here. And it seems like we have done pretty much the same syntax. One thing I want to try though, since this is a regular int8 pointer actually, maybe we can do this and we can let this default to the evil raw. Maybe that could actually work. Let's see what happens. Okay, that's nice. 621. Right, this should point to the address of the counter. Assignment to int32 makes integer from pointer. That's correct. We changed the type of this thing because before we had the IP source and IP dest as a pointer, so we need to, let's see here, we need to change these into int8 pointers instead. Like so. And what about this? Expected identifier or blah, 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 blah. 639. This shouldn't be IP equals, it should be IP packet equals. Same here, IP packet. What about this? Incompatible types when assigning to type layer 4 from type raw star. Okay, it's the same thing here. This needs to be the payload dot raw packet. And now I believe it will compile. And it did. Okay, so how do we test this out? I think I'm gonna, let's see here. Let's log out from this server and attach to this screen. Let's connect back to this server and into the Ester directory, and let's reset this to our home. And then I'm going to connect to another server, my air gap server. And here we can listen for the packets, and then we can use the other one to send. So let's see. 10126. Let's grab this MAC address. Or no, actually. Since this is on another network, we can't just um, we can't just send an Ethernet frame to it without using IP, because it needs to go through a router. It would be better if both of these servers were on the same local network. But that can be arranged. We need to set up a temporary network just for these two. So let's see how we can do that. We need to put them on the same local network, basically. So let me log into my virtualization server. Where I have all my virtual machines. It's a quite cool server, this actually. I have it in a data center outside of Stockholm, and I have 192 gigabytes of RAM in this. So it has potential for a lot of different virtual machines. Alright, so let's see here. We need to set up a new network. So what are we gonna call this one? Let me see. Let's call it Esther, same as the project. And let's just pick a VLAN ID for it. I don't know, 1500? Maybe that's too high. 800. Okay, so now we need to create network cards on these two servers, and I think I can do it while they are still running. I'm not 100% sure, but I think so. So let's go into the Intel 32 machine. Settings. Add network adapter. And this new should be on the Esther network, like this. And then we go into the air gap machine, which is this one. We do the same thing. We add a new network adapter and make sure that it's on the Esther network. Like so. And if everything has worked, we should see a new network adapter here. So currently we have 192 and 224. And now we have 256 as well. That's good. So let's give it some kind of IP address. So this 256 should be 172.25.01, let's say. And let's make it a /24 network. And let's activate it. And then we go to the Intel 32 machine, log in as root. And this is the interface, so 224, and we have 172.25.0.25, let's say. Alright, so if this network works, we should be able to ping the other side of the link. Let's start by pinging ourselves. So 172.25.0.25, that works. And what about .1? That works too. Let's just, for the sake of it, try pinging the other side from this one, 0.25. Alright, that looks good. So how do we monitor if we are able to send the Ethernet frames? I'm not really sure. We're going to use TCP dump, that's for sure. And we want to see Ethernet frames. Can we just type Ethernet? Ether. And Clay replied in the wrong context. Because sniffing for IP packets is quite simple, but how do we sniff for Ethernet packets? Maybe we can give it let's Google. So TCP dump Ethernet. The problem is this is going to listen for filter by MAC address. That's good. TCP dump ether host and then the MAC address. That's good. That's very good. So let's go into our other machine. And let's use the real MAC addresses for now. So our brand new network card has the following MAC address. And TCP dump wants it in this format. So let's see. And it's called 256. So we'll run TCP dump -n-i ENS 256 ether host, this one. Alright, it's listening. So let's see if we can do this thing. By the way, we need to grab this machine's MAC address as well. Okay, so the source MAC, that is ours. Let's save this here first. So this is our MAC address. Alright, so our source is this one, and we need to format it properly. And our destination is this one. And our source IP is 172.25.0.25. Destination is 172.25.0.1, and the message is hello. And we need to run this as root. Okay, return equals true, but I don't see anything here. Wow. Why is that? Let's see if we can get some information by running strace. No such device. I think we need to specify what interface we're going to send this thing over. Okay, so how do we do that? I guess we need to do a bind operation. So let's prepare for that. SOCFD, soc address, soclent address length. Wonder if this is the right thing though. Let's check the packet manual once again. Use bind in specifying an address and a soc address LL. Alrighty then. Soc address LL. Let's create one of those. So this we can do inside of the setup function. So we need to have a struct soc address LL. Let's call it soc. And what do we need to put in here? SLL family, always AF packet, okay. SLL family is this. And protocol, that's a 0, no. I guess it's this thing, okay. The soc SLL protocol is the Aton S of Ethernet P all. IF index, right, we need to figure out what number the interface has. Let's wait with this one. HA type, ARP hardware type, what is that? When you send packets, it's enough to specify blah 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 blah. And this is for receive. Okay, so let's wait a little bit with this stuff down. So this is equal to something. And packet type, we can also wait with. What else we got? Yes, we can't forget this one. We need to set this one, but for now I will just do this, because this we need to do some other lookups and stuff. So HA type, packet type is done. HA len, length of address. Is that in bytes or? I guess it's in bytes. Well, a MAC address is 6 bytes, 48 bits. So length of address is 6. And then we need to specify the MAC address in a char. Weird format to save a MAC address in. Well, no SLL address. So I guess we will need to string copy then. Do we have a string copy function? No. Well, we can use the regular copy. So let's copy into the int8 version of sock SLL address, and it needs to be the address of this. And we want to copy the source MAC, which we need to define. And the size is going to be 6 bytes. So we need to take 2 arguments here. We need to take an int8 with the interface name and an int8. Well, let's do this. Mac source Mac. So I guess we need to. I'm not really sure how we're gonna do this, but let's do this. let's clean out the structure before we do anything else. So with 0 over sock, size of struct sock address LL. Alright. And this right here, the if index, we need to create some function which turns an interface name, such as ETH1 or ENS256, into an index number that the operating system can understand. So let's call this if2 index. And we need to provide the interface. Alright, something like this. So now we need to do a couple of things. First we need to modify the signature so it matches this, and then we need to modify the call site as well. Let's see here. Let's go down to our setup function, which is now going to take an indate star and a MAC address pointer. And at our main function, we need to modify the usage first, because now we need to provide an interface as well. And in our main function, we need, now we need to move everything. Well, it's not that difficult. So this will be 2, this will be 3, this will be 4, this will be 5, and this will be 6. And we are going to need an interface, and the MAC address we have already. So let's set the interface equal to argv1, like so. And let's check this validity as well. And down at the setup function, let's see here. We need to provide the interface and the source MAC address. Alright, let's go back to the setup function. So what did we have? We wanted to create an if2 index. We can create our signature for now. Maybe we can add it here. So it's going to return an index. Let's say an int16. Or let's actually do an int32. And before I forget, let's also convert this into an integer. Let's do it in 16. We're not gonna have more than 65,000 interfaces, I hope. So we have an interface and we want an index, and we provide an int8 pointer to the interface we are talking about. And when we have all those things and we have a socket, we want to bind this to that socket. So our TMP is going to be equal to bind, and we provide our S. That's a socket file descriptor. And then I guess we need to cast this into a struct sock address. And we provide the sock and size of struct sock address. LL. Something like this. And let's check for bind's return value. I think it's supposed to be 0. On success, 0 is returned, otherwise -1. And if we have an error at the bind, we will close down our socket. That's the S. Well, if socket fails, we should return an error, right? Well, something like this. And same here, return 0. Okay, so that's it. Now we only need to do this thing. Figure out how we can turn an interface name into an interface index. And I guess we need to linearly search through all the indexes and compare the index name. So this is going to be an int 16 if2 index, and we'll have an int8 interface like so. And how do we do this? How can we figure out how to do this thing? Turning an interface name. Well, we know that the ifconfig command needs to do this because it prints all the interfaces. So if we were to run this in strace, pipe it into a file, then we maybe be able to find something which makes sense. ifconf. This might be it. So ioctl is the system call, and let's remember this cgifconf. cgifconf. Maybe this. No, that's not it. Is there an ioctl ifconf? How do we search in the man table? F. There must be a command to list everything which contains the search word. What about A? ioctl? No. Regular expression. That sounds good. So we should be able to do ioctl dot plus. Ha! Look at this. All right. Do we have something appropriate here? Not really. What if we were to search the contents of the man page for CGIFconf? How do we search the contents? Okay, so the manual pages are stored at this location. Maybe we can just search this then. If we do something like grep-r cgifconf in this directory. Nothing. What about just ifconf? We don't get anything for ifconf either. Maybe that's not correct location. User share man. Oh, it's in GC. That explains it. So let's use zgrep instead. R option not supported. I wonder, I think I have done something like this before. Let's see here. If I go into my repo and my, what did I call this? DDoS, umbrella. I think I did something like this here. This is an old project which we're trying to it was trying to block denial of service attacks. This is the right thing, I think. Get IF addresses. Get, um, get IF addresses. Huh, here we are. So it was a specific system call just for this purpose. Get interface addresses. Creates a linked list of structures describing the network interfaces. A linked list, okay. So this IFA name is the string name of the interface. Do we get the ID or the index somehow? Or do we need to just count them perhaps? Okay, so now I see. This does the opposite, basically. This compares the IP address. So we give it an IP address and you get back the interface name. But what do we do with that interface name? We call stats init. Okay. Well, let's try. Let's go through that list and just count the interfaces, and let's try if that becomes the index. I think that's the best idea. So let's add the headers. So we need to have one of these structures. Let's see. Struct if addresses. We also need to have one for each individual address. And something for the return value. Something for the index. So ret is going to be equal to get if addresses. This is not a system call, this is a library call. Maybe we can try to go deeper when we get this to work. Does it mention any system call for this? No. Well, we'll see. So we need to provide the address of the head of the list. And what's the return values? On success, 0. Okay. So how can we signal an error here? Let's do something like this. All right. So now we have the head of the list. We need to do a for loop where we set p equal to the head to begin with. And we're going to iterate as long as what okay, until it's 0. So as long as we have a p, and at each iteration p is going to be equal to p something IFA next. something like this. And what do we want to do at each of this? We need to compare the interface address, and we need to keep count as well. So let's initialize our index to 0 and increase it by 1 every time. And if this p if name, I guess, yes, well, we need to compare this. Do we have a string compare function or something like it? We have copy. Let's write one very fast. So bool string compare. And we have an int 8 a and int 8 b. Bool string compare int 8a int 8b. So we need two pointers, an a pointer and a b pointer. And a bool for the return value. Let's initialize it to true. We do a for loop where we set a pointer equal to a, b pointer equal to b. And we're going to loop as long as well, we need to have both an a and a b. And at each iteration we want to increase the a pointer and the b pointer. So something like this. And we want to check if the current position of a pointer is equal to the current position of b pointer. And if they are not equal, then we want to set ret equal to false and break. And then we can just return ret. That should go through these two strings and compare them one by one. So if string compare of this thing here, if this is equal to the interface, we need to signal somehow that it actually completed. So let's do the same here. We'll do a bool ret or bool OK. And let's set our OK to false. But if this happens, we want to set it to true and break. So by the end of this thing, if we didn't find it, we can do this. if we didn't find it, we want to return an error. Well, we can't return an error here, so let's do this instead. Let's assert that, but it will not look very good. Let's rename this to found interface. And I renamed this variable just so this assert message, if it fails, will be more understandable. So let's assert that found interface is equal to true. And if not, it will exit. Otherwise, we will return the index. And I guess we need to free this structure at this point as well. Free IF addresses. Do we need to free every single one of them? How do they do it in an example? Okay, they just free the whole thing. Or no, they can't really do that, can they? It's a linked list. Well, maybe they can. So, free IF addresses head. I guess this should work. Let's see if it compiles. From incompatible pointer type. Maybe we shouldn't do this. Cannot convert to a pointer type. Well, it is a pointer, so I guess we just need to... where was it? Here. Guess we can just do this. I'm not sure if this is going to work though. Well, we will see. We will see. 689. This should be Mac source. What is this? Head is used uninitialized. Okay. Let's see here. We could make this like this as well. So let's do head and P. And let's put the address here as before. And do this. And do this. Okay, compiles. That is good. So let's see. First, let's check what the name of the interface is. This. And let's see if we find the last time we ran this. Here. So now we need to add the interface name here in the beginning. Okay. Still don't see anything though. So let's see the bind operation, SSL protocol, IF index, IF name to index. ENS 192. But what is this thing here? Mappings between network interface names and indices. So there is a function for this. netif.h, do you have this? No. I want to test this function and see if it returns the same thing as ours do. Let's create a temporary main function. Unassigned int. So how do we call this? if name to index and just provide a string. Okay. On error 0 is returned. Okay, so the index cannot be 0. That's interesting. Alright, so something like this. And let's create a signature at the end here. Uh-huh. That makes sense actually. Because our starts at 0 and theirs can't return 0 because that would be an error. Right. So that's good actually. That means that we can actually return an error without doing the asserts. So if2 index. So instead of asserting this here, we could just do this. And same down here. So if we haven't found the interface, we return 0, otherwise we return the index. And we will start our index at 1. Okay, exciting stuff. So let's try this again. Okay, this time it uses the right interface at least. And our source MAC address is this 000C. Okay, it does not look right. No, wait, it is actually 000C 299F. It worked. But why doesn't it send our packet? Message too long. And why doesn't it return an error? Why does it return ret is equal to true? That is the first thing I want to fix. If we have a ret, we return true, otherwise false. So the send frame must not work properly. Our return value, which is a signed integer, is equal to send. Okay. We need to do something like if the return value is more than 0, then we want to return true, otherwise false. Okay, that makes sense. So our problem is message too long. Message too long. The socket type requires that message be sent atomically, and the size of the message to be sent made this impossible. That's weird. Let's see if we can print this. Well, let's print the size first. $2,000, 27,000 bytes. Yeah, that sounds a little bit too much because our message is just hello. How is that possible? The payload itself is very much too big. I guess it has to do with that we never null terminated it. Could that be the case? Let's see, how does our main look like? Raw packet is equal to the message. Let's try use some temporary buffer. Int 8 buff 16. And instead of setting this pointer here, or we can set it, but let's do a let's copy. Let's see here. Let's copy into our buffer this argument. Something like this. And then we can set our message pointing towards the buffer instead. Will this make a difference? Let's also go to our send frame. And let's quit after we have done this. Still the same thing. So that's not it then. I have an idea. We have a couple of main functions. And our main for used to work. So let's see if it still works now. This is a good way. Saving all the main functions previously is good in occasions like this. Okay, so here it works. So what is this exactly? We have Ethernet packet and an IP packet. But does it still work if we have an ICMP packet in addition to that? How do we create one of those? Make ICMP. We need a type. I think we need to look at the actual function. Make ICMP. Okay, so we need a kind, we need some data, and a size. And this data needs to be a pointer, which we already have. Okay. So let's go to our main for. And let's add one of those. So ICMP packet. Let's say our ICMP packet is equal to make ICMP. And we need a kind. Let's say this is echo. We need some data, ABC. And the size of this is 4, including the null byte. This needs to be int 16, 4. And our IP packet payload is going to be, or payload dot ICMP packet is going to be the ICMP packet, like so. Corrupted top size. Okay, because the ICMP packet in turn does not have a payload. Okay, so we need to create a ping packet. Let's do that then. We need to have a struct ping. What did we call it? S ping? No. Yeah, S ping. This is the so this is the ping packet then. And what does it contain? ID seek data. Let's say the ping packet is equal to struct as ping malloc, and we want to malloc the size of struct as ping plus 4 bytes, let's say. And then we'll set the fields. So the ID will be something. The seek will be something else too. And the data and this is an array, so we need to take the address of this. Let's copy ABC, size 4, or 3 in this case, I guess. Okay, so now we have a ping packet. So we can set the ICMP packet to, no, wait here. When we create the ICMP packet, we need to refer to the ping packet as its data. So this is going to be the ping packet. And we need to calculate the size once again. Struct as ping plus 4. right? Okay. ICMP packet payload, kind echo, size 8 bytes of payload. That makes sense. This does not look right though. Corrupted top size. So we are basically overwriting the heap somehow. I wonder what would happen if we just wanted to send an empty. So we have an Ethernet header, an IP header, but then an empty payload to this. Something like this. Would this work? Okay, at least it doesn't crash. So let's go to our send frame and remove this exit. Okay, ret is equal to true. And we got something, didn't we? Let's see if you send it again. Yes, we get something. From this MAC address to our correct MAC address. So we are able to send an Ethernet frame. And this program interprets this as a DSAP packet. Maybe that's because if we check etc. protocols, so protocol 0, which we're currently using, IPv6 hop-by-hop option. But we are able to send an actual Ethernet frame, and that was our primary intention at this point. So this is pretty cool. Can we spoof our MAC address? Let's see if we can. If we wanted to create an artificial one, let's say 0001 38A4 9900. It didn't like that. We did not get an error though. I wonder if it has to do with our let's see here. Maybe it became the wrong interface or something. Well, we can figure that out later. But this is pretty cool, actually. So I think this will be enough for today. We have successfully been able to send an email. I hope you liked this episode. So please like and subscribe. And I'll see you soon. Thanks for watching. Thanks for today.